Hey guys, Lindsay here, and today I'm going to talk a little bit about graphing an equation of a line, and we're going to do that in our first few examples here using a table of values. So let's take a look at the first example I have written up here. 2x subtract y plus 4 equals 0. That's an equation of a line, but I can manipulate that equation around all I want as long as I don't change it. I can change the places of these, and I'm going to do that because what I'd like to do in order to use my table of values is get y by itself. So I'm going to take this negative y and I'm going to bring it to the other side of the equation. So now this is still the same equation, 2x plus 4. But because this negative y came to the other side, now it's positive y. And actually, I'm going to rewrite this as y equals 2x plus 4. So I've just flipped everything. Same equation. So that's what I want to do for a starting point. I want to get y on its own on one side, and I want to have everything else in the equation on the other side. And now I'm going to set up my table of values. So basically, all a table of values is a column for x, a column for y, and then in between the two, I'm going to have what y equals. So in this equation, y equals 2x plus 4. So I'm going to write that here, 2x plus 4. Now the nice thing about a table of values is I get to choose the values. Because if you think what we're actually ultimately trying to do here is, this says graph that line. Here we have an x and a y axis. This would be the y axis, up and down. If you ever wonder how to remember that, if you think, shake your head, yes, up and down, that's the y-axis. So y is up and down, x is left and right. I want to plot this line on that graph, but I can actually choose whatever x values I want because there actually are an infinite amount of x values on a line like that. So let's choose our values and let's make them easy to work with. Let's choose -1, 0, and 1, for example. I could keep going if I wanted and have more points, but I think 3 is probably enough. And I've chosen those numbers because they're really small. They're easy to work with. So what I'm going to do now is I am going to take this value for x, -1, and I am going to plug it into that equation. So wherever I see an x, I'm going to put a -1. And then here for y, I'm going to solve that equation. 2 times -1 is -2 plus 4. That's positive 2. So what that tells me is when x equals -1, y equals 2 on that line. So why don't we just over here write -1, 2. There is our xy point that we'll plot over there in a second. Let's do the same thing for 0. I'm going to rewrite this, but instead of writing an x, this time I'm going to write a 0 plus 4. 2 times 0, 0 plus 4. Well, that's 4. So there's another point on the line, 0, 4. So I'll write that there for you. And let's do that one more time with 1. If I wanted, I could put an infinite amount of x values, but I think 3 is probably enough. It's a straight line, so we're going to join them together to create that line. So 1, I'm going to put a 1 where I see an x. And then I'm going to solve that. 2 times 1, well, that's 2 plus 4. Is 6. So this point would be 1, 6. So now I have 3 points that I'm going to plot over here, and hopefully they line up so that I know I've done my math correctly. I've got -1, 2. Now unfortunately I don't have graph paper, so we'll hope that this is to scale as much as it can be. -1 represents the x value, and 2 represents the y value. So -1 on x would be about right there, and 2 on the y would be about right there. So that point would be -1, 2. Our next point is 0, 4. So our x value is 0. I don't go to the left or to the right. I stay right in the center, but I'm going to go up because it's positive. I'm going to go up 4. 1, 2, 3, 4. So about right there. Now, I could join those 2 points together, and that would be my line, but I do a third one just to make sure that those are correct. If I've made a mistake, it's going to be obvious in that third point. My third point is 1, 6. So this time, I'm going to go +1, and then up to 5, up 1 more, so 1, 6 is about right there. And again, the reason I did 3 is so I can see those 3 line up. If I had 2 points that lined up and 1 point way over here, I know my math's wrong and I can go back and check that. I've got my 3 points. I'm going to join them. And that, I'm going to put arrows on the end because it goes in both directions infinitely. So it could go on forever, which means, again, any x point will have a y value as well, no matter where it is, which is why I could choose any one that I want. Let's label this. So let's call this line y equals 2x plus 4. So that's an example of that line. Let me make myself some room, and then we will graph this line on that same plot so we can sort of see the difference between the two. All right, guys, let's take a look at a second example. So over here, I've got 2y plus 6x equals 18. I'll write it here so it's in front of us. And if we are going to graph this using a table of values, the first thing I want to do is I want to isolate y. So let's get this 6x away from the 2y, so the 2y is on its own. 6x, positive 6x, crosses over to the other side. It now becomes negative 6x. And then that positive 18, it hasn't moved, so it stays a positive 18. But I don't have a y yet by itself. I've got a 2y, so I need to get rid of that 2 in front of the y. It's stuck to that y. There's no plus or minus in between them. So the only way to get rid of that 2 is divide it out. If I do something to one thing in an equation, I've got to do the same to the others. So let's do that. So now I have y equals negative 3x plus 9, and that is the equation that we're going to take a minute and graph using a table of values. So let's set that up again. Remember that we have an x column, we've got a y column, and in between the two, we have, right here, negative 3x plus 9. So we're always going to write not what we had originally, but whatever y equals, that's what goes right in the center. I can choose whatever values I want for x. I'm going to choose negative 1, 0, and 1 again because they're nice and easy to work with. So if you chose different values, though, in the end, our line is going to look the same. So let's do negative 1. So I've got negative 3 times negative 1 plus 9. Negative 3 times negative 1, that's 3, plus 9, I've got 12. So my point, let's make my list of points down here. Sorry about all the craziness. We've got negative 1, 12 as my first point. Second point, I'm going to plug 0 in for x. Negative 3 times 0, 0, plus 9 is 9. So 0, 9 would be my second point. And then my third point, negative 3, I'm going to put a 1 in, plus 9. Negative 3 times 1 is negative 3. Negative 3 plus 9, that's 6. So my third point is 1, 6. So I've got 3 points here, and I'm going to plot those 3 points. We'll use yellow this time, just change the color up a little bit. So negative 1, 12. Negative 1 on the x-axis would be right there. 12 is way, there's 10, so 11, 12, right about there. We'll sort of improvise a bit with the space we have. Now we've got 0, 9. So 0, not left or right, but the y value is 9, so I'm going up. 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. Too bad we didn't have graph paper on here. The last one, 1, 6. So 1, and then up to 6. And again, the reason I did 3 dots instead of 2 is because that kind of helps me pull out an error if I have one. But since the 3 of these line up, I know I don't, which is great. So I'm going to join them. And I'm going to continue that line on forever in both directions. And I'm going to label that line y equals negative 3x plus 9. So hopefully that helps you a little bit with creating a graph of a line using a table of values.